Today's lesson is on the ambiguous case. The law of sines is known as ambiguous because it does not always result in a unique angle solution for a triangle. In fact, the law of sines can result in one or two possible angles in any given scenario. Which case exists is easily determined by solving your trig equation that results from our law of sines. Remember the formula for the law of sines is sine of angle A over side A equal to sine of angle B over side B. Any proportion between two sides and two angles works. The reason that there could be two possibilities is because in a triangle, the sum of all angles is 180 degrees. And if I think about where 180 degrees is located, I'm in the top half of my unit circle, and in both of these quadrants, sine is positive. The easiest way to determine whether or not you can make multiple triangles is to just go through the question and solve each side. So when I read a question that says, in triangle RST, I am given the following information, I'm going to start like we did yesterday. I'm going to create my triangle. So angle R, 105. Or I'm sorry, yes, angle. Side R, 9. Side S, 6. So because law of sines is all about pairs of information, in this situation here, first thing we're going to do is we're going to solve for angle S. So let's set up our law of sines. So sine of 105 degrees over 9 equals the sine of angle S over 6. Remember, when you're looking for an angle, this is where you use that inverse trig button on the calculator. Let's cross multiply. Divide by 9. And then into the calculator, we're going to go inverse sine of our entire proportion. So our calculator is going to be this, inverse sine of. Then we're going to put all of our proportion in this parenthesis, and this is going to result in the value for angle S. Okay, so over here I get inverse sine. Mine always goes crazy. So we have 6 sine of angle 105 divided by 9. This results in an angle of approximately 40 degrees. You could go 40.1 if you want for a little more accuracy, but approximately 40 degrees. So here, I come back. I'm going to put my 40 degrees right here. And now here's how we decide whether we can make one triangle or two triangles. If I know angle R and I know angle S, I can easily solve for angle T. So if I'm thinking about steps, step 1, use angle S to find angle T. Ask yourself this question, does this make a triangle? So if I come over here, I got 105 plus 40. Subtract from 180. That tells me that angle T is 35 degrees. Does this make a triangle? Answer to that question is yes, it does. All angles add up to 180. So guaranteed one solution in this question. To determine if there's another solution, I take my angle S that I found from the first quadrant, and I see if I can go ahead and put this angle in quadrant 2. Is that possible? Well, in quadrant 2, we go 180 minus our reference angle. So that would be 180 minus 40. This is 140 degrees. Is it possible to put 140 degrees back into your triangle where S was? Answer to that question is no. Because look what happens if I add my optional angle here of 140 to the 105 that was given. I'm over 180, which is not allowed, so we reject that one, and we say we can only have one solution. So just so you know, for step 2 here, we ask ourselves, can the reference angle be used in quadrant 2 and still fit with the given information? This time that answer was a no, which is why we rejected it. Let's try another one so you can practice because it takes a little while to get used to that rule. So this triangle's already been drawn and labeled for us. It is asking us to determine all possible values for the measure of angle C. Not necessarily how many triangles can you make, but how many angles work at C's location. Really the same thing as how many triangles. So if I want angle C, I set up my proportion. So sine of angle B over side B equals sine of angle C, which we don't know, over side C. Cross multiply, divide by 6. And because we're looking for the value of the angle, we're going to go inverse sine of our entire proportion here. That's going to give us the first possibility for angle C. So we go inverse sine of our proportion. Our proportion here was 10 sine of 36 degrees divided by 6. This gives us approximately 78.4 degrees. So angle C's first value is 78.4 degrees. First thing I do is solve to make sure that that fits triangle ABC. So 78.4 plus 36 is less than 180. That's what we're going for. Meaning I can find angle A by doing 180 minus 114. Okay, that's going to work. So that makes one triangle. Second angle I'm looking for has to fit in quadrant 2. So to see if I can draw a second triangle, which would look like this, by the way. All the same information, but this angle is going to have a different measure. To get that second angle, I look for quadrant 2. Subtract from 180, I get 101.6 degrees. Notice that 101.6 and 36, when we add them together, we still are less than 180. This means a second triangle can be made because our angles, all three, would still be under 180 degrees. So if I wanted angle A, I would just subtract. So this 101.6 works. So here, the first angle we solved for made one triangle. Putting our angle into quadrant 2 made a second triangle. So if we're looking for all possibilities for angle C, we have 2 of them. So far we've seen an example where only one triangle can be built and an example for 2 triangles. Let's see what this next example is going to give us. Always start with your picture, just like you do with law of sines, because that's what we're using here. Angle A, 54 degrees. Side A is 6, side B is 8. I'm looking for angle B. Set up our proportion. Sine of 54 over 6 equals sine of B over 8. I'm sure you're getting used to this formula by now. Divide by 6. We're looking for the measure of an angle. So we're going to go inverse sine in order to find angle B. I need to see what you're typing in your calculator because I'm letting you use that to get your work. So I've got to see what you're putting in there. So when I go over here, I go inverse sine of my proportion, which happens to be 8 sine, oops, hold on, let's try that again. That fraction, there we go, 8 sine of angle 54 divide by 6. This time we get an undefined. What do you think that means if it's undefined? Well, if you're thinking if it's undefined it doesn't work, you are right. This means that no triangle can be formed with the given solution, or with the given information. Let me show you why this gives you an undefined. If we just take a look at this value that's inside of our parentheses, just this piece right here. If I have 8 sine of 54 divided by 6, I want to show you what that equals on the calculator. I'm going to type that in one more time without the inverse sign there. I want to show you that what we were evaluating that resulted in an undefined value was we were asking it to do the sine of 1.0786. If this equals 1.0786, notice that this is outside the unit circle, more than a value of 1. We know that anytime we are solving an equation when the value is more than 1, it got rejected. So that's what happens here. We would have to reject this value. That's why the undefined happens. So here we know no triangle could be found. Last one for practice together. Maybe this time you want to try it on your own. Pause the video after you get it set up. Solve it, then play the video to see if you are correct. We're looking for how many triangles can be formed. Set up your proportion. Cross multiply. Divide by 8. And let's do inverse sine of our proportion. That's going to help us find angle B. Mine's being finicky. All right, 21 sine of 47 divided by, oh, I don't know, I have 21 there. I think I want an 8 there. Is that correct? Or a 10? Let me go back and read the question. I want a 10 for sure. So let's fix my mistake here. Get rid of that too. So 10 sine of 47. No, hold on, everybody. Sorry. Yeah, 10 sine of 47 divided by 8. I got 66.1 degrees for angle B. So I come over to my triangle, and I know that 47 and 66 is less than 180. So I like this value. Allows me to solve for an angle C. So right away, I keep that 66.1. Next thing I do is I go to quadrant 2. In quadrant 2, does that angle work to make a second triangle? This looks like I'm going to get 120, 113, sorry, 113.9 as my second possible value. Does that 113.9 work with the 47th? To know if it works, it just has to add to be less than 180. The answer to this is yes, it works. So that means here we have two possibilities for triangles that can be formed. So here we have two solutions with our given information because it makes two distinct, different triangles. Okay. You are going to try for homework the couple questions on pages 10 to 11. Oh, nope. Am I going to lie on that? Let's see. Oh, yeah, no, that was, it just didn't say homework. This is homework. Okay. Pages 10 to 11 for homework. Your answers, and I will see you on Monday. Happy weekends.